Hi, in today's tutorial we will build a ship classifier using TensorFlow and Xception with a ship dataset from Kaggle. We will load and preprocess the images, map labels into 5 categories like cargo, military, carrier, cruise and a tanker, and then apply data augmentation to make the model more robust. Then we will train Xception as a feature extractor, evaluate results with a confusion matrix, and finally run predictions on real ship images, overlaying the class name directly on the image. You are most welcome to subscribe my channel, and also you can see this playlist that contains more tutorials about image classification. Let's run a short demo and explain what we are going to do today. First of all, we will take this dataset. This dataset is a dataset that is composed of ship images, and basically it contains 5 categories of ship images: cargo, military, carrier, cruise and tanker. After you download this dataset, you will see all of these images. You can see all the images are located in the same folder and they are all mixed together. The information about the categories for each images is inside this CSV file. So if we will go back to the code, we will learn first of all how to prepare the data. Then we will build a model that it is based on the Xception pre-trained model on this architecture. We will learn how to build the model and how to train it on our custom dataset, and we will configure it for our needs for those 5 categories and images. And after that we will take one image. This is a cargo image for testing our model, and we will code the inference process, and after that let's run it, and this process will take the image, prepare it for our model, run the prediction and display the right category, which in our case is a cargo. You can see here this is our test image, and it says here that this is a cargo image. So let's start with the first process, which is the installation part. So let's start the installation part. First of all, we would like to work with TensorFlow that can use the CUDA environment, meaning it can run using a GPU card. So in order to do that, we are running the Windows PowerShell, and then we will run the WSL that enable us to run a Linux environment. You can see that we are running a Linux environment under the Windows. You can also see that we have a Conda, the basic Conda environment, and in this process we would like to create a new Conda environment. And all the instructions will be in the installation file. Let's run the VS Code so we can open the installation file. So after running the VS Code, this will be our installation file, and this is our working folder named Xception Ships Classification. So what is important to understand? First of all, you should run the PowerShell as admin, and after that you should run the WSL that enables you to use a Linux environment. Then we will create a new Conda environment. We will name it TensorFlow tutorial. Of course, you can choose your own custom name. Just to clarify, you can copy this, go back to the PowerShell and then paste it here, and it will run the command and create this environment. After that, we are activating this environment, and then we should install TensorFlow. In this tutorial we will use TensorFlow 2.16.2. If you have a CUDA installed in your local machine, you can run it with this command: pip install TensorFlow and CUDA equals 2.16.2. If you don't have a GPU card, you can run it on CPU as well. It will do the same functionality, but it will be a little bit slow in the training part. And after that, you should install these 5 Python libraries: OpenCV, NumPy, Pandas, Seaborn, and sklearn. We will use all of these Python libraries as part of the coding. And then of course you should run your IDE. I'm using VS Code, so the command is code space and a dot, and it will run the VS Code. To finish the installation, we need the dataset for the coding part. I skipped the first line. You can see here that I have pasted here the link for our ship dataset. So let's go to the browser, and here you can see we have a ship dataset that contains about 9,000 images, and also it contains a CSV file that contains all the names, the file names and the category. And we have 5 categories. Cargo is 1, military is 2, carrier, cruise, and tanker. So each of those images has its corresponding label in the CSV file. So basically we have to run through the CSV file and prepare the data for our model. So our first step will be dealing and preparing the data. The second step will be building the model, and the third step will be testing and running inference of our model. So in this step, click the download button, and after that extract the zip file. There is another subfolder with the train images. Let's make it a little bit bigger, and now you can see these are the images, and here is the CSV file that contains the extra information about each image. So I believe that now we are ready to start the first step. Let's change our current environment to the one that we just created, TensorFlow tutorial. So now all the code will run on this Conda environment. Let's create a new Python code, and this will deal with the data preparation. So let's name it prepare the data.py. Here is the link for the dataset. It will be part of the code, and you can download from the video description. So we are starting with importing the libraries that we will need for this tutorial. And now let's define the path for our training CSV file. This file contains the mapping between image names and their categories. So we will load the data from the CSV file and run through all the items inside it. Using pandas, we will read the CSV into a data frame. I'll also print its shape so we can see how many rows and columns it has. Next, let's create a dictionary to map numerical categories to their actual ship type. This will make our labels more readable. In the dataset, categories start from 1, so let's shift them down by 1 to match our dictionary. Then we will map them to the string labels using our dictionary. And finally, I'll convert them into pandas categorical type for efficiency. And let's take a quick look at the first few rows to confirm everything worked. Let's run it. Great, you can see the result. This is the shape. We have more than 6,000 images, and here are the categories. Now, before training, it's always good to explore the data. I'll plot a count chart to see the distribution of the sheep categories. So in order to do that, we will use the Seaborn library. So let's choose a title, the X label and the Y label, and let's display the result. I have to update the argument for the count plot. Now it's okay, and let's run it. Great, now we can see how many sheep we have in each category. Now it's time to load the actual images. So here's the path where all the training images are stored. And next I will grab the list of image file names from our data frame. Let's prepare an empty list to store the actual image data, and let's loop through each image file name. I'll print the image name so we can follow along. For each image we will build the full path, read it with OpenCV, and next we will convert it from BGR to RGB since OpenCV loads it in a BGR. We will resize it to our required dimensions, 128 by 128 pixels, to keep everything consistent, and we will append each of the images into our list. After the loop, let's convert our list into NumPy array. This way our data is ready for TensorFlow later. And finally, let's save this array to the disk, so it will be useful. We don't need to reprocess the images every time we will return to this notebook, and we will use it later for our training. Let's run it. So here's the loop. We can stop the recording and continue to the next step. So now we are ready to build our model. As a starting point, let's save as our previous step 1 to step 2. Let's name it step 2 train, and we will use the initial code, so it will be required for the training. And now let's load the pre-processed image tensor we saved earlier, and we will store it on the X variable. So this is the full path for our data, and let's print the shape just to double check that everything is okay. We're expected to see the same amount of images. You can see more than 6,000 images. Next, one hot encode the numeric categories into vectors for softmax training. So let's elaborate about it more. Basically, 0 mean cargo, 1 mean military, 2 mean a carrier, 3 cruise, and 4 tanker. So these are the initial categories. After doing the one hot encoding, cargo 0 will become with the value 1 in the first positions, and all the rest will be 0. Military, for example, will be the value 1 on the second position, and carrier will be the value 1 on the third position. So this is basically the process of one hot encoding. Next, let's split the data into train, validation, and test dataset. So we will use the function train test split from the sklearn. First, we will carve out a test set. Then we will split the remaining into train and validation. So in the first process, we will extract 15% of the data for test, and next we will extract 20% to create the validation dataset. After that, we will create data augmentation to help the model do better results. So we will use horizontal flips, rotations, zooms, and shifts. This will make the model more robust for the training. Now let's build the model. We will import Keras building blocks and the Xception backbone. We will add a light classification head on the top. So here we are loading all the relevant objects and functions. Now let's define the training hyperparameters. Let's start with the bed size. 100, it's a little bit high. I believe we will change it later. And let's run it on 50 epochs. Then we will load the Xception model pre-trained on ImageNet with the top layer removed. Input shape is 128 by 128 by 3 channels. And this will match our resized images. Global average pooling converts feature maps into compact feature vector. A final classification layer for 5 ships categories with softmax activation. After that, we are creating our model variable that contains the head with a single model. Then we will compile the Adam optimizer and categorical cross entropy for multi-class classification. And finally, the training process. We will train the model using our augmented generators. The steps per epoch ensure each epoch sees roughly all training samples, and validation data is used for monitor the process. And after training, let's evaluate on the held out test set. We will generate predictions and compare them to the true labels. So basically we will create a confusion matrix and we will see the result on the confusion matrix. We can compare the true labels for the true labels and the predicted labels. Now let's build the confusion matrix to see where the model confuses classes. The heatmap gives a quick visual of per class performance. Let's choose the label, the X label and the Y label. And after that, finally, let's save the trained model in a Keras format so we can reload it later and test it. We will store it on our temporary models subfolders. Of course, you can store it on your custom folder. I have some syntax error, let's fix it, and let's change the batch size to 16. Also batch size, we have to fix it in the rest of the places. Let's run it. Now the training has started. I will run it on a fast forward process. So this is the first epoch, this is the second epoch, the third epoch. So I believe we will start recording now, and let's jump directly to the end of the training. So the training has finished, and now we can see the confusion matrix. And as you can see, I believe almost all of the results are here on this diagonal of, we are on the left side see the true labels, and here the predicted labels. So all the for example, if we take category 1 as a true label and category 1 as a predicted label, we have 158 samples that are true, and we have about 3 plus 2 plus 3 plus 6, so approximately more than 10, about 15 samples are wrong. But I think if we see all the results here, most of the samples are in the right position. So I believe that now we are ready to write the code for testing our saved model. So now let's test our train exception model on a brand new image. This will be our test image. It's a cargo image. So let's create a new Python file. Let's name it step number 3, test the model. Let's start with importing the relevant Python libraries, and after that we will load the saved model we trained earlier. Make sure that the path matches where you saved the model. So here is the model path, and then we will use the function load underscore model. The next step, we will load the image that we would like to classify. We are using a test image of a cargo ship. So let's copy the path for that image. So let's see if the model can detect that correctly. So after loading the image, we will resize the image to the same input size the model expects, 128 by 128, then convert it into a Keras compatible array and add a batch dimension. That means batch dimension, that it's basically a batch of images that contain, in our case, only one image. Of course, we can send several images for the prediction. Now let's run the prediction. The model outputs probabilities for each class, so we can take the index of the max value. And after that, let's map that predicted index back to the ship type using the same dictionary we defined earlier. To make the result more visual, let's draw the predicted class directly on the image. So we will define font, size, color, and other setting for that text. And next, let's get the text size so we know how much space it will take on the image, and then we will position it near the top left corner. So as you can see, we are grabbing the text size, and then we will define the X and Y position. Now, to make the text stand out, we will first draw a black rectangle behind it. It's like a background behind the text. And after that, now we are ready to place the prediction text on the top of the rectangle. Finally, after putting the text on the image, let's display the image using matplotlib, and we will convert it from BGR to RGB so the colors look correct. Let's run it. Let's grab the image. As you can see, this is a cargo ship. It was detected correctly. So thank you very much. You are most welcome to subscribe my channel. More videos will be uploaded soon.